All right, everybody. We're the Brilliant Butterflies group, and the name of our product was TIMRI, which is an acronym for Tumor Identification in MRIs. So during this presentation, we'll kind of just be going over everything we progressed over this past 3 weeks. We'll introduce our team, kind of go over our project itself, show our trailer video, explain how we trained and augmented our data set, some of the hyperparameters we had to switch during our model training, the metrics of our final two models, our website, and then the application of the model itself. So this is our team.
All right. I'm Ara. I'm going to be a senior next year. I'm currently in California, and I was the backend developer for this project.
I'm Brendon. I'm a rising sophomore, and I primarily worked on the front end, building the website. Yeah, and Brianna's unfortunately couldn't be here today because she had some urgent matters to attend to, but she was also working on the back end.
I'm David, and I'm a rising sophomore, and I was the front end.
I'm Junchen, and I'm going to sophomore next year, and I worked on backend.
I'm Vanessa. I'm a rising junior, and I was the project manager, and I worked on the trailer and machine learning. So just as an overview of our project, our team created a CV model that combines both a classification model and an object detection model in order to identify glioma tumors and localize meningioma and pituitary tumors. And these are all brain tumors from MRI scans. So this is our trailer.
Can you hear it?
You guys have to
No,
share
I don't
sound.
think so.
You have to share sound, like go up to more and then share sound.
Okay, just give me a moment. I did share sound. Is it audible?
I don't think
Yeah.
I think is the sound on? Like is the
Yes,
sound
it is.
recording? Okay.
How about
Maybe
now?
No. Okay, we will share this video at the end of the presentation, maybe with the YouTube link. Sorry for that.
Okay.
You can go to the next.
Wait, Ara, if you're presenting, I can't see your screen. So is it on the data set screen?
Yes, I'm
Okay.
presenting right now.
Okay, that's fine. So we used 4 different images. We used images with meningioma tumors, pituitary tumors, glioma tumors, and then we also had images of normal brains with no tumors in them. And for our estimated size, we had about 5,400 images for classification and 2,900 images of tumors.
So here are our augmentations. During pre-processing, we resized our photos to 640 by 640, and we also auto-adjusted our contrast through histogram equalization augment. And we also adjusted the brightness of photos between negative 15% and positive 15%. And we also adjusted exposure of photos between negative 5% and positive 5%.
It was okay. I think Kiana definitely good presenter.
So these are our hyperparameters that we obtained from our most optimal model. After countless hours of training our model with different types of classes, we finally got an optimal model called Gentle Meadow 60. We first annotated our data sets in YOLO-V5. We got the weights and biases, which we then transferred onto Google Colab to train. So from our most optimal model, the batch size is 25. We used a large model size, which allows for more processing to be done within the data set. We also froze about 15 layers approximately, which allowed our neural network to be trained efficiently, and we trained it for approximately 40 epochs. So these are our object detection metrics that we obtained from our most optimal model. On the left, you see our F1 confidence curve, which is all classes at 0.87 at a confidence of 0.457. This F1 confidence curve just reflects the predictive performance of our model, whereas on the right, you see our precision recall curve, which is our mean average precision. All classes are at 0.896 at 0.5.
So for our classification model, we had an accuracy of around 99.44%, and the loss value was around 0.02. Just to make things really simple, the higher the accuracy is, it's obviously going to make the model perform better.
Unfortunately, as we are not licensed medical professionals, we did encounter some roadblocks while we were trying to let our robots, find the tumors in the MRI scans. And since, as it says, with the untrained eye, we had difficulty identifying glioma tumors to label. So our only solution to this was to only classify it, and we weren't able to localize it.
And here's our real-world application. Our technology works to enhance the accuracy of a doctor's diagnosis and reduce the risk of a misdiagnosis in brain tumors.
And here's our website, which I will now demo now. So we have our heading, our mission, and this is our trailer, which I hope there's sound. Can we hear it now? Oh man.
No, like we will say it's demo it after this presentation.
Just without sound?
No, we'll demo it afterwards. You can continue.
Afterwards. So our mission, including our video, all of our metrics from object detection and our classification, image classification model using Google Bit, our timeline, which we brainstorm project ideas, gathering data from Kaggle and creating our data set and whatnot. We used all of these resources. We used Kaggle, RoboFlow, Google Colab, Hugging Face, Gradio, and Runway, and our team as you know it. And I will be demoing the project now. Here we have multiple examples of meningioma, pituitary, and glioma tumors. And we also have some examples of MRI images with no tumors at all. So for instance, if I click this image here, it shows bounding blocks over this meningioma tumor in an MRI scan. And if I click this certain image, it shows a pituitary tumor, and it drew bounding blocks with confidence of 0.84. And some additional examples. So that is basically our project that we developed over the course of 3 weeks. Thank you for listening.
Any questions?
Do you think you guys can send the website in the chat?
Yeah,
Yes.
so I already put the link, but I'll just resend it again.
Okay, thank you.
Also, I will share the trailer right now. Just a second. Yeah. Enable the sound. Are you guys able to see my screen?
Yeah,
Just let me know whether you are.
94,000.
Are you able to see hear this audio?
we can hear the audio, but I don't think on the screen we can see the video. Like it's just like your Windows.
Okay.
background.
Are you able to see my screen?
Yeah, I think it's fine. You can play it and you'll pay a thing, I guess.
You're just showing your desktop.
Oh
Yeah,
yeah,
you're
it's
just
just
showing your-
modem. Yeah.
I think it's because you're only screen. Maybe try screen sharing your window, your entire screen, not just a window.
Are you able to see my screen now?
Yeah.
Yes.
Okay. And then this is the issue. No issue.
390. That's the number of Americans who will be diagnosed with a brain tumor by the end of this year. 18,990 will die from one. Current solutions are not enough. Brain tumors are often difficult to diagnose, commonly resulting in misdiagnoses or delayed diagnoses until it's too late. And as each day, each moment goes by, the risk of death for someone with an undiagnosed brain tumor only increases. Introducing TIMRI, Tumor Identification in MRIs. Trained with over 2,500 unique MRI images, our tumor identifying model can detect glioma tumors and localize meningioma and pituitary tumors from MRI scans within minutes. With an image classification accuracy of over 99%, our model can help reduce the risk of any future misdiagnoses and increase the reliability of a professional's diagnosis, finally giving patients the safety and confidence they deserve. Within the course of this day alone, 52 individuals will have died from brain tumor-related complications. Stop this cycle, starting with TIMRI.
That's it. Thank you, guys.